Okay, so this is day 2 of the final review packet for academic success. I thought we'd start off with a little bit of domain and range because we all love domain and range. Remember guys, domain simply is the set of all possible x values. Now if that doesn't make any sense, I understand. Basically, the x-axis, right, moves left and right. So the domain can be seen as the most left values all the way to the most right values. Right, so the leftist piece to the rightest piece. So from here, if we look at this e function here, like this letter e, the leftmost point happens right here. And what is the x-coordinate of that leftmost point? Well, that's going to be -2. And then it's going to go as far right as right here. Well, how far to the right is this? Well, it's to the right by 2 as well. Now, if you're doing the regular notation here, just regular inequalities, it would be an x in the middle, and you would say that x is going to be less than or equal to the 2 and greater than or equal to the -2. Now, it has to be equal to because the dots here were filled. If you hadn't noticed before, if you look on your packet, you'll see that they're filled. Those of you who want to do it in interval notation will do a -2 to 2 with hard brackets, if you remember to do that. So some of you, your teacher wants you to do that, so just, this is regular inequality, and this is interval notation. So pick your poison. Range. Well, domain is the leftist point to the rightest point, which means range is controlled by the y-axis. So the bottomest of the graph to the toppest of the graph. So how far down does this graph go? Well, it goes as far down as -3, right? The -3 is the y-coordinate of this low point right here. How far up does it go? Well, it goes as far up as 2. That's the highest that it goes. And since the range is y instead of an x, I'll put a y here. And again, because the dots are closed, that'll be the greater than or equal to signs. And if you wanted to do that in interval notation, it would be just like the domain, except it would be under the heading of range. So from here, if we look at B, domain, what is the leftist part of this graph? As far left as it goes will be -3. And then, how far to the right does it go? Well, this arrow here means it's going to go on forever, which means you could write it, if you wanted to keep the same notation as this inequality, it would go as far to the right as forever. And forever in math is written as infinity. And since we never get there, we can't really put the equal sign, but we can certainly put it on the -3. So how does that look in interval notation? Well, that's going to be 3, infinity, soft bracket because we can't get there, so soft bracket because there's no equal sign, and hard bracket around the, -3, not 3, -3. So real quickly, range is going to be looking like -2. And then it's going to go as far up as infinity again. Now, why is that? It's because this guy's shooting up slowly. But if I go way over to the right, it's going to start going a little bit more up. And way over to the right, it's going to go a little bit more up. And way over to the right, it's going to move a little bit up. And the further right I go, the further up I go. And because this guy goes right forever, the graph has no choice but to go up forever. So that is why the range is from -2 to infinity. Now let's look at D. So, domain. I think we can kind of move through this one a little bit faster. This arrow means it's going to go furthest to the left forever. So where's way over to the left? Well, that's going to be -infinity. This arrow says it's going to go way off to the right. That's going to be positive infinity. And x is going to be in between them. Again, I can't get to infinity, so I'm never going to put an equal sign there. The range. Does this thing have a lowest point? It certainly does. It's right here. It goes as far low as -1. And these arrows are telling me to shoot all the way up, all the way, all the way, all the way up. What is all the way up in math talk? It is infinity. And if you wanted to do that in interval notation, you could just say -infinity to infinity. And then you could say -1 to infinity. You would get to the -1 because the dot actually lands there. And then you don't get to infinity ever. So that is domain and range for the first few problems. Speaking of things we all love and enjoy, let's talk sequences again. So when it comes to sequences, we're being asked to write for this arithmetic sequence an explicit and recursive equation. Well, let's go and talk about the explicit equation first. Well, that's going to be t of n, right, is equal to, I need to find a slope of this thing, right? So how am I moving from one term to the next? It looks like I'm subtracting a value. It looks like minus 12 each time. So that tells me that it's going to be negative 12n. Now again, just like last time, in order to get this term right here, I need to find the 0th term. The 0th term goes there. So it looks like if I subtract 12 to move to the right, in order to get to the left, I'm going to add 12. So whatever 27 plus 12 is going to be what number I put in here. You guessed it, it is 39, and that is your explicit sequence. Hopefully recursive is getting easier because it's always set up kind of the same way. The t of n plus 1 is how to get the next term. The equal sign means is. What I do is I always use the current term, which is t sub n. And then how does that current term change? Well, it just gets subtracted by 12 each time. So that's your explicit and recursive formula. On to number 4. List the first 5 terms of each geometric sequence. Well, t of 1 equals 100. What does that mean? T of 1 is the first term, meaning my first term is 100. Now, how do I read this recursive sequence here? Well, remember, t of n plus 1 is the next term. The next term is t of n, which is the current term, times 1/2. So, what does that mean? To get to the next term, which is this guy, I take my current term, which is 100, and I multiply them by 1/2. What does that mean? 100 times 1/2 is 50. 50 is now my current term. My next term after 50, I will take the 50, which is my current term, and multiply him by 1/2, getting me 25. Next, it will be 25, which is my current term, times 1/2, 25 over 2. And last, 25 over 2, which has now assumed the role of the current term, times 1/2. So that will be 25 over 4. Now, I will be willing to bet that some people are confused by this. So, what does that look like? 25 over 2 times 1/2. How do you multiply fractions? You multiply the tops together, and you multiply the bottoms together. 25 over 4, sure as anything, is my next term. Which means, if I was to write another term, it would be 25 over 8. Good job. And so on and so forth. Here's something interesting. Writing a multivariable equation, solving for the indicated variable. So, they want me to solve for w here, which means get w by itself. So how do I do that? Well, if I got to get all the stuff away from w, I got to find out how things are being stuck to w. Well, I got a bunch of stuff stuck to w here. In fact, let me go and change colors on w. I'll change him. There you go. So, how would I do this? Well, I'm going to go ahead and move all the stuff away. So imagine if this was, say, 3x plus 5 equals 19, what would you do? You would subtract the 5 first, because that's the addition portion, right? So I'm going to do the same thing here. I'm going to go and subtract 9 from either side. Now, believe it or not, p minus 9 is easier than 19 minus 5. Because 19 minus 5, you have to think. You could make a mistake. It's 14. That took some thought right there. I had to actually do some subtraction. P minus 9 is easier than you think. Because p minus 9 really is just p minus 9. And that is equal to negative AW. Just like over here, 14 would be equal to 3x. How do I remove on my right side? This is what we're familiar with. How do I remove this 3 attached to the x? I divide by 3. And I get x equals, hey, the best fractions are the ones that can't be reduced. 14 over 3 can't be reduced, so we're done with him. So how did we get the x by itself? We divided by 3. How am I going to get the w by itself? The negative a is attached to w by multiplication. So I unmultiply it by dividing by negative a. Now, the wonderful thing, just like 14 can't divide by 3 evenly, p minus 9 divided by negative a can't divide evenly also. So the wonderful thing about this problem is that you end up with a fraction that you really just can't reduce or simplify or anything, and it's a nasty answer, but nevertheless, it's an answer. Okay, that'll do it for this video. Go and get to work on more solving equations, writing equations of lines, more domain and range, exponent rules, and sequences and series. See you soon.